Okay, this is a study team test for Chapter 3. Congratulations, we have completed our third chapter. We are starting Chapter 4 at this point. Chapter 4 rather, happens quickly. There's only 10 days in it. That's where the 10 came from. But I hope you find this helpful in reviewing what happened on the study team test and identifying more problems that you might want to practice or check out with me as you prepare for the Chapter 4 test. So first question asks us to simplify. We were given 4 different expressions, and we talked about a lot of the little individual things that involve getting to a simplified expression. Basically, again, simplification is reducing the number of operations necessary to evaluate an expression. And one thing that we dislike, we're avoiding, are negative exponents. So for question A, I'm told that I've got xy squared raised to the third power. So I'm looking at it, and kind of big picture, what I see here is that I have exactly 3 of these factors, this factor grouping that looks like y or xy to the second power. So I'm just going to choose to write that out 3 times, right? I've got an xy squared, there's 1 of them. I've got another xy squared, there's 2 of them. And finally I've got an xy squared. So there are 3 xy squareds. Now as I look at these, I see that I'm multiplying an x times another x, right? They're exactly 1, 2, 3 factors of x. And when I use the notation of exponents to write that down, that's x to the third power. The other thing that I see is that I have a lot of factors of y. In fact, if I count them, there's 2 factors of y, that's y squared, 2 more factors of y, 2 more factors of y. Altogether, that's a total of 6 factors of y. So I write this as times y to the 6th power. So remember what y squared means. It means yy. So you can see I've got this yy, yy. So there's 6 of those factors. So part A, the answer is x to the third and then y to the 6th power. Let's look at part B. Part B has a negative exponent, and we want to deal with that right away. The way that we deal with negative exponents is we've been multiplying by the exact same base with a positive exponent that cancels out, or doesn't cancel out. It forms a 0 with the exponent that I have. So, and I can't just multiply by 1 over this, right? I have to do the same thing in both the numerator and denominator. So if you look at it, what I'm doing here, big picture, is I'm multiplying by 1. Therefore, I'm not changing this expression at all, right? I'm just changing its form. So it'll still be equal to the same thing. But now as I look in my denominator, I've got there is this 15, but you can see I've also got a to the negative 5th and a to the 5th. Well, when I combine that, that's a to the 0 power, which equals 1. So if I take a look at it now, mission accomplished. I no longer have a negative exponent. What I have is I have 5a to the 5th in the numerator, and in my denominator I just have the number 15, right? 15 times 1. There's one more thing I should do. There is a common factor here of 5. Right? So I might choose to write it as 5a to the 5th over 3 times 5, and this way I can see this 5 over 5, this giant one that's lurking in this problem. But my final answer is going to be an a to the 5th power, and I over 3, right? A to the 5th power is in the numerator, and there's a 3 in the denominator. So I'll write that down. Whoops, a to the 5th and over the number 3. Let's go to question C. Question C, I have lots of factors of x. In fact, if I look closely, there are 2 factors of x. That's xx, and then I have xx, xxx. So that's a combine, if you listen to what I said, 7 factors of x, right? 2 of them and then 5 more. So I can write that. I can write it this way, right? 1, 2, 3, 4, 5, 6. But there's 7 of them, so I'm just going to choose to write it as x to the 7th power. And the other thing that I have is a 4 times a 3, right? 4 times 3 is 12. So C is 12 x to the 7th power. And then my final expression, if you look at it, I guess I'll think about this as a giant one. I'm going to rewrite the numerator as x to the 3rd times x to the 4th power. And when I do that, and why I did that is because I can see, I'll be right there, I can see that in my denominator I have x to the 4th power. right? So I have 2x to the fourth. So this forms a giant 1, right? So it just equals 1. So what I'm left with here is x to the third over the number 2. So my answer for D is x cubed over 2.